The mysterious lights of Proxima Centauri b. The scientific community is currently gripped by a discovery that could change our understanding of the universe. Astronomers using the James Webb Space Telescope, JWST, have detected strange, urban-like lights in deep space, specifically from Proxima Centauri b, an exoplanet located over 7 billion kilometers away. This exoplanet orbits Proxima Centauri, the closest star to our Sun, making it a key target in the search for extraterrestrial life. But no one expected this. A glowing signal, faint yet persistent, rising from the surface of this distant world. These unexpected observations have stirred both excitement and caution among scientists. Why? Because the lights resemble artificial illumination, not unlike the glow of city lights seen on Earth from orbit. The idea that such lights might come from intelligent activity is bold, yet impossible to ignore. For generations, humanity has gazed at the stars with hope, curiosity, and endless questions. Are we alone? Is Earth the only cradle of life in the cosmos? This discovery could mark the beginning of a new chapter in that ongoing quest. While scanning Proxima b, the JWST picked up infrared signatures that didn't align with normal planetary behavior. Typically, rocky planets absorb solar radiation and emit it as heat, visible in the infrared spectrum. But this planet showed thermal irregularities, hot spots and patterns that defied explanation. Dr. David Kipping, an astronomer at Columbia University, weighed in on these anomalies. He noted that Proxima b displays a non-natural heating pattern, an infrared signature that may point to heat sources beyond mere solar absorption. This is where the lights come into focus. Using its advanced sensors, the JWST can detect incredibly faint light emissions, even through the vast darkness of space. Its ability to observe narrow light frequencies, up to 1,000 times finer than typical starlight, gives it an edge in spotting these subtle differences. Some researchers speculate these lights might not be natural at all. They might be indicators of artificial energy, perhaps created by an advanced civilization attempting to harness or generate power on the night side of their planet. Such possibilities, while speculative, are grounded in real science and physics. It's especially interesting that Proxima b is tidally locked, meaning one side always faces its star while the other remains in perpetual darkness. On Earth, this would be like one hemisphere basking in eternal daylight, while the other lives in unending night. Could this strange environment encourage a civilization to illuminate the dark side for survival or expansion? Might solar panels line the day side, collecting energy to power structures or infrastructure on the night side? While these questions may sound like science fiction, they are taken seriously within astrobiology circles. The unusual light signature could represent something entirely new, either a breakthrough in natural planetary science or a potential glimpse of alien technology. But before jumping to conclusions, researchers are carefully analyzing every possibility. Could volcanic activity explain the heat? What about atmospheric reflections or mineral compositions? These are questions the JWST and supporting observatories are now working to answer in detail. That's where the investigation turns toward the planet's atmosphere, the next major piece of the puzzle. Proxima b's atmosphere, clues to alien life? Following the detection of mysterious lights on Proxima Centauri b, the scientific spotlight has now shifted to another critical aspect, its atmosphere. Why is the atmosphere so important? Because it serves as a natural laboratory, a dynamic system where gases interact, sunlight filters through, and clues about surface and subsurface conditions accumulate. It's often the best place to search for indirect signs of life. Astronomers are hunting for biosignatures, gases like oxygen, water vapor, methane, and ozone, that are commonly linked to biological activity here on Earth. If we find these gases, especially in unusual combinations, it could indicate active processes that mirror what we see in Earth's own biosphere. This is where the James Webb Space Telescope, JWST, plays a vital role. With its remarkable infrared sensitivity, JWST can analyze how starlight passes through a planet's atmosphere during a transit. This technique, called transmission spectroscopy, allows scientists to decode the light spectrum and identify which molecules are present by their distinct absorption patterns. JWST is especially good at detecting water vapor, carbon dioxide, and methane. Oxygen, however, is harder to detect directly in the infrared spectrum. That's why ozone, a byproduct of oxygen, is an important alternative marker. Its presence could point toward an oxygen-rich environment. What's particularly fascinating is the detection of methane and ozone together. These gases normally react and cancel each other out in the atmosphere, so if both exist in measurable quantities, something must be replenishing them. On Earth, that something is life. However, nature can sometimes create false positives. Volcanic activity, solar radiation, and even chemical weathering can generate methane or other organics without life being involved. So scientists must be cautious. They need to look at not just individual gases, but the overall chemical balance and atmospheric behavior. Context is key. Is the atmosphere in equilibrium? Are the gases layered or evenly mixed? Is there evidence of active climate processes or seasonal variation? All of these clues help narrow down whether life could exist, or if something else is at play. While JWST leads the charge, it's not acting alone. A new generation of Earth-based observatories is on the way, including the highly anticipated Extremely Large Telescope, ELT, in Chile. With its 39-meter mirror, the ELT will be able to collect more light and deliver sharper images than ever before, offering deeper insights into distant planetary atmospheres. The ELT will work alongside JWST to not only study chemical compositions but also reduce stellar glare, making it easier to observe reflected light from an exoplanet's surface. Such reflections could tell us about oceans, continents, or even artificial structures if they exist. If the urban-style lights observed on Proxima b are indeed artificial, future telescopes may detect repeating light patterns, thermal inconsistencies, or even signals that vary in a controlled, non-random way. We might also see evidence of seasonal atmospheric changes, just as we do on Earth, shifts in carbon levels or cloud cover that suggest weather patterns or life cycles. Even without direct proof of life, a rich, chemically active atmosphere would still be a major discovery. It would mean Proxima b is far from being a barren rock. It's dynamic, evolving, and possibly habitable under the right conditions. This is the kind of breakthrough scientists have been working toward for decades. For the first time, we can go beyond simply locating exoplanets. We can now begin reading their atmospheric stories, learning what they're made of, and asking how they've changed over time. Whether these mysterious lights are signs of intelligent life or natural phenomena we've never seen before, the implications are profound. And so, the ultimate question persists. Are we alone in the universe? We don't have the answer yet, but the technology, data, and international collaboration now in place are finally giving us the tools to get closer than ever before. If this cosmic journey intrigued you, don't forget to like, subscribe, and tap the notification bell for more updates on the search for life beyond Earth. Thank you for watching, stay curious, keep exploring, and we'll see you in the next